I'm going to have a look at and compare the two latest 13.5 turn motors for 2017 racing, competition racing. We've got the Muchmore Fleta, the 30.5 turn ER, and we've got the latest R1 motor, the R1-135B-125-V16-Ultra Premium, both legal for touring car racing, 2S. And also I will be looking also at this optional rotor for the Muchmore. It's a Titanium Spec rotor. It is going to be legal to use as an optional rotor. It's got a different Gauss reading, and be interesting to see how it changes the performance. It's also very expensive. Side by side you see they're both the same sort of matte black colour with the Fleta has nice silver detailing. The R1 is just got some silver detailing here. So first of all, you can see that you can see the windings quite easily through the large gaps. There's huge gaps on here on the Muchmore, and the cooling gaps on the R1 are also good, giving you plenty of cooling that can get through to the windings. The fronts, the R1 still has a machined alloy front which is fixed to a centre can press in, whereas the Fleta now has the whole can goes from there to there as one piece, and that slides off on some, and some it's tight, won't come off. 3 screws on the back for holding the centre board in place, the end, which is good. 1 sensor socket at the top, and on the R1 it's down the bottom. Scales 0 to 60, and I think it goes 0 to 10, 20, 0 to 50 on the Muchmore. You can just check the feel of the magnets force. I just turn them, they feel very similar to turn. The Muchmore has a specification written, engraved onto the flat part, 12.5 by, I can't quite read it. This one not so much. The Muchmore has the flat engraved for the pinion. Grub screw goes in a lot further. This one stops quite early, so that might be a good point if you're trying to fit the pinion on one way or the other. The stator length, I should be able to measure it across here, and we can see it. It's also got 13.5 ER engraved on there. The R1 just has 13.5 etched on the case. V16. This one has 13.5 type ER on the back as well. So we can compare the weights. The R1 weighs 152.9, and the Muchmore weighs 150.8. Muchmore stator resistance 0.026, R1 stator resistance 0.025. Stator length, the Muchmore, the epoxy insulation stops nicely halfway up the stack, the front, so you can get calipers on front and back. It looks like 19.66. Measuring the R1 stator length, the end of the laminations, the one on the front and the one on the back, seems to be a slightly different lamination to all the others. It's got like a black finish on the front, so it looks like they've made a lamination with an insulation on the face. that is different from the other ones, because you can see just a little gap if you look very closely, where the other laminations are really pressed together, and the outer ones look like they put on last and they don't quite fit exactly tight. But measuring the length, 19.9, about 19.93. Going to set the time in and adjust and test this, but the R1 comes set at 50 degrees on the end bell, whereas the Muchmore ones come set at 30 degrees. For comparison purposes, I've tuned the timing on the end bell so I can get a 6 amp reading, and you can compare directly. And now a lot of people just look at the revs, and I must say if the revs vary with the input voltage, so if you're going to compare revs between motors, you've got to make sure that your LiPo voltage is always permanently the same. I do it by keeping the battery here on charge with a charger completely connected at all times, and keep it charging to 8.4, so I get a consistent results at all time. Now the whole point of the KV is the RPM divided by the volts. So if this was a higher voltage, say 8, the RPM would be higher, but the KV would be the same. If the voltage was lower, say 7.4, the RPM would be lower, but one dividing to the other, the KV comes out the same. So it's the KV that you're looking at, not the RPM, because the RPM varies with the voltage. Anyway, that said, I've got a reading here for the R1, and I'll put the Muchmore on next. Timing for the 6 amps on the R1, it's varying between 45 and 49, so not a really tight end bell sensor, average of 46. End bell markings, it's right there, about just over 55 degrees, but the meter's showing 46. The Muchmore one tuned to 6.0 amps. It's got a KV of 4110, and the revs 32,475, but at 7.9 volts, so it's slightly less revvy than the R1. Motor timing, much less required, and the nice sensor board very close, 43 degrees and 43, 44, 43. Timing on the end bell is just about 45 degrees, so it's looks like the scale is fairly accurate on the Muchmore. Taking two motors apart to compare the construction and have a look what's going on inside. We've looked at the Muchmore one previously, the 17.5, but we can look at it again. Construction, and you can see that they're quite a lot different. The R1's still pretty conventional as used by most manufacturers now, with the stator pressed into a cylinder for the center part, and then there's an end bell at each end. The front end's got this alloy machine part, and the end bell at the end is also alloy construction with the sensor board. Now the sensor board in this one has got the nice sleeve around it, which means that when it's assembled it's kept pretty much square when they sold it up, and it's not twisted like some of them are. There's a heavy duty spacer that goes on the back of there. We'll look at that in a minute. Just still comparing the motors, the Muchmore one has the this new design of sleeve, including the front part all in the sleeve, all in one. Sometimes the stator is a press fit in both of them into there. Sometimes these come out, sometimes they don't, depends on the tolerance. This one is nice, has a nice fit but it just came out. These are forced in, and generally you can't get them back out again. Now this one has the sensor board also with a nice sleeve around it, holding it dead square. Different design of sensor board on the Muchmore. This sensor board looks fairly conventional, like you've seen in quite a lot of other motors, possibly from the same source. Now looking a bit closer, the R1, looking at the stator design, personally I don't think it's the best. The front part that they solder the wires onto completely blanks the front part out. Luckily they've got these large holes for air to get in. This front part seems to be made out of a machined piece of aluminium, possibly for heat sinking. They relying on the heat to come out through the wires into this and onto the outside of the case. And one thing I noticed with the R1 is, because they don't use the plastic former like most of the modern motors, when they put the wires on, to stop it cutting through on any sharp edges on the steel of the laminations, on the R1 they put a piece of like thin sort of paper material. Whoever's wound this has been pushed in, and then the wire wound on tops just to stop it cutting through, and then a bit of epoxy has been sort of wiped onto it with a brush. It's a bit haphazard, and it blocks off a bit of the wire for cooling purposes. It's covered the wires over, and these slots. Another thing you notice that the wires just come up and are soldered onto these plates. They're not riveted at all, so they can bend backwards and forwards. Though with this part jammed on the top, that gives it quite a bit of support, so it shouldn't be a problem. There's no additional rivet put in wrapping around the wires, which I've seen on some motors, which gives you a much better soldered contact to the wires. This relies on just the wires poked up through the hole and soldered, and in fact you can see the hole's quite big, and they've just filled the hole in with solder, which means if you overheat this motor, the solder can run off and give you a bad connection where the wires just poke through, just relying on the solder to hold it in position. And the front has been, I don't know how they solder to this aluminium, some special solder anyway. You can see the stator where it's pulled out on the Muchmore. You can see that their stator has got a layer of epoxy, the green, which is a more expensive process to put that on than just pushing a bit of paper type material in, which means that there's none of that paper hanging around, so there's no blocking of any airflow around the coils. Now you can see how they've soldered this on. They didn't use a rivet sleeve either, but the solder's nicely run all the way down the wires, and the soldering job looks a bit neater to me on this than on the R1. Whoever soldered them, I would say the Muchmore one is a nicer job. Also you can see that these are riveted to stop any movement at all, but they still use a little paper insulator to stop any shorting onto the back of the case. This one is much thicker, it's almost a piece of fiberboard. And the front plate here is much smaller than the R1, which means that you can still get some airflow around it, though they have got a bit of insulation there to stop the wires rubbing and perhaps shorting out eventually if there's any movement. On the R1 they don't have that. The wires are just clear of that plate. You can just see a gap, so they obviously relying on the wires not pressing against that plate. Different manufacturers use different techniques. So those are the stators, the sensor boards, 3 screws on both the cases. Now the only other main part, of course, is the rotor. The Muchmore has a lot of engraving on it. It says Muchmore. It's got the size 12.5, etc., and it's got a code MR. I think it says MRFZR21V, and it's even got it engraved on the end as well. So they've really gone to town. It's got this little alloy part on the front, which is normally drilled for balancing. They've got no holes drilled in it, so it must have been well balanced. And a little like O-ring for taking out any pressure when you shim it nice and tight, so if it expands it squashes the O-ring, so that's all nice. There were other shims on there that I've taken off. Just be careful that you don't lose them and you know where they came from. I'll measure the Gauss of that in a second. The R1 rotor, again, it's got a little aluminium part glued on the front, but on this one they put epoxy in for balancing, which is a technique that's been around for a long time. Nothing engraved on the shaft, but it's got a number sort of embossed, engraved or printed on there, which says, I wrote it down, it says R1-125B-125-V16-Ultra Premium. Different shape, it's got a step on the end, and you can see that the middle part is quite big. On the Muchmore one, you can see the centre part there, but there's no step. I'm going to measure the Gauss in a second. Be careful with these rotors, you don't want them to bang together. Gauss of the Muchmore rotor, as fitted in the 13.5ER. 1368 approx, and then the negative pole, say 1380 odd. 1370, 1380 odd. So not perfect north and south poles, but the Gauss on the 17.5 that we measured was a bit lower than that, about 1350. So looks like these rotors vary slightly, or they select them for these motors. Gauss of the R1. Stronger rotor, looks like it's about 1450, minus 1430, about plus 1450. So a stronger rotor on the R1, which means that's going to give well, better bottom end in theory. Now the optional Muchmore rotor, the MRFZR21TIZ, says it's a Titanium Spec rotor, 12.5 by 7.25 by 24.2. Let's just measure the Gauss on that. Let's put a spacer. Sort of a gold part on the end, again not drilled, so there's no balancing being done. It's engraved with Muchmore and the code on there as well. So let's just check its Gauss reading. Looks like it's a 1400 they've aimed for, minus 1403. Oh, perfectly made though, the plus and minus poles being the same, 1403. Oh, spot on, a well made rotor. Now that's, I'm not sure if I can weigh these rotors, so the difference, I'll put it into the motor and test it and see what difference it makes to the performance. Okay, weighing the rotors. To keep them off sticking to the plate, I put something to put them on, and you can weigh them. The R1 weighs 25.3. The Muchmore weighs 26.3, and the Titanium version weighs 22.2. So it's lighter in weight by a couple of grams. Should be good for rotational acceleration. Okay, with the Muchmore with the optional titanium rotor fitted, retuned the end-build timing slightly. It's the kV's gone up to 4661. That's a massive increase, and the revs have gone up an awful lot. So if you're going to use this optional rotor, you probably have to make sure you gear the car to make use of the high revs, i.e. with a smaller pinion. And the timing is still 45, 46, 45 with the optional titanium rotor to get comparative 6 amp readings. Just as an experiment, I put the R1 rotor in the Muchmore. It fitted straight in there, fitted on the sensor board without any problem. Seems to position itself exactly the same in the stator. So I wound it up, and but it gives a lot lower RPM and kV because of the extra strength. After testing the motors and taking them apart, what's the conclusion of the R1 versus the Fleta? Well, they're both the latest cooling design, as you've seen, with big slots for getting the air out, making sure that you can run them without overheating. The Muchmore is a more radical design, and I must say the construction and quality of the Muchmore seems better than the R1. But that doesn't necessarily mean it's going to be better. So let's have a look at the results. I've tested the R1 and the Muchmore, and then with the optional rotor in the Muchmore, and also I tried it with another rotor from the R1. So you'll notice now that these latest batch of motors have very high kV ratings. Looking at previous motors, the Phantoms, for instance, the V2T and V2Rs, the kVs are only in the 3700 range, similar to previous RevTech motors. They were 3637, and the earlier Phantom version 1s, for instance, were actually better, higher kVs, 3924. Anyway, looking at the kVs on these, the R1s got the highest when set at 6 amps, over 4200, the Muchmore 4110, and at 6 amps, and you can see the timing. The Muchmore needs slightly less timing. Normally less timing is a good thing, which means that it has a slightly wider torque band, but the R1 is beating it just a bit on the kV. Before we look at the optional rotor ones, just look at some of the other figures. The weight, 150.8 is the Muchmore, is the lightest in weight, a couple of grams lighter than the R1. Previous motors have been up in the 160 gram range, except the V2R Phantom got down to 157.9. So these motors are getting lighter all the time. Resistance to the winding, which is important, is the resistance. Windings will heat up, there will be heat loss, and the R1 just beats the Muchmore, is 0.026 ohms versus 0.025. Small difference, but always the lower the better. Now the Gauss on the rotors, it's interesting that the R1 has a higher Gauss, getting on to 1450, which should give it a very good bottom end. The Muchmore has gone for just under 1400, which should make it very revvy, but we know from the 17.5 that it still has plenty of bottom end in racing. And so that's the differences of the two motors there. Now when you add the titanium rotor into the Muchmore, you get a huge change. The kV is really high now. The revs have gone up a lot, the kV has gone up a lot, but the rotor is not weak to give you that. It's still a 1400, very good 1400 Gauss rotor. So with the optional rotor, this motor would be incredible, I think, as long as you gear it right. Now remember, these high revs and high kV motors, you must gear them right. If you overgear them, they won't go. So you've got to be fitting smaller pinions than you've been using on previous motors, and this one in particular is going to be quite difficult to gear. You're going to end up with even smaller pinions getting on towards a modified motor. I also just put the R1 motor in the Muchmore. It didn't come out great. The kV was down at 3.8, which was not good. It didn't seem to like the extra strength, that nearly 1450 Gauss, or it didn't line up properly. It seemed to line up properly, so it was just an experiment. It did fit in okay, but the results were not worthwhile. So which one to run? Well, both of these are going to be extremely fast motors, but you've got to gear them right. If you overgear and use pinion sizes like you've done on your previous motors, you'll bog them down, they'll get hot, and you will be disappointed with the performance. So it is critical now that you get the final drive ratio right. They look like they're both going to be really good. I can't say which one as standard will be better. I'm sure they're going to be very similar, and it'd be just down to, I think, how you set them up and use them. But I think they're both going to be race winning motors.